Say you wanted to solve for x in the quadratic equation, ax squared plus bx plus c equals 0, and a, which is your first coefficient to the far left, is a non-zero number. And to solve this, to find those x values, you would use the quadratic formula. What is the quadratic formula? Well, it's the following. X, which is your solution, or solutions, is equal to minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. You might be thinking right now, where do you get that? Where do you get the right side of that equation, and how do you know that that whole thing will give you the values of the quadratic equation to the left? Well, we're going to do the proof. We're going to show how to derive the quadratic formula, and to do that, you would use the exact same technique that was done in the previous video, which is completing the square. The general technique involves taking an expression of the form x squared plus rx, all right? So you have x squared plus rx. You would take that form, and you're going to try to find a number that you can add so that you end up with a perfect square, right? You want to do all of that process. You find a number so that you can add to this, and you end up with a perfect square. You end up with something like this, x plus n squared. All right? It turns out if you add r divided by 2 squared, then you can factor it as a perfect square. So if you do r over 2 and all of that squared, and you add it to this expression right here, you're going to end up with a perfect square. All right, so let's do an example. So suppose you want to solve for x in the equation above, right? ax squared plus bx plus c equals 0, and a is a non-zero number. Then the first step of the previous video, which was completing the square, was moving that constant number, which is the c, to the right side, right? You're going to subtract it on both sides, all right? And you're going to divide by a, which is the non-zero number, all right? So here we go. Let me use another color so that we can tell that this is the part where we're completing the square, okay? You're going to subtract c on both sides, then you divide by a. So you end up with x squared plus b over a, x equals minus c over a. All right? You subtracted the c on both sides. On the right side, you're left with minus c, and then you divided by a on both sides. The a cancels out with the ax squared, and you have b over ax for the bx. And then on the right, you have minus c over a. Okay, perfect. You have the first two steps. To write that left side as a perfect square, notice first how we have this form. You have an x squared with a coefficient of 1 in the front, and then plus rx. R could be a rational number, and this is what you have there. You have a rational number in front of x. Now you would have to add a number so that you end up with a perfect square. To write the left side as a perfect square, you use what was mentioned previously. You have r right here. That is going to equal to b over a in this case. So you add r over 2 squared, and in this case it's b over a over 2 squared to both sides. What's that going to look like? Well, you have r. Let's write it over here. R is b over a. Well, r over 2, well, that's just going to be b over 2a. And then r over 2 squared, that's going to be b over 2a squared. This is what you're adding to both sides. All right, so on the left side, you end up with x squared plus b over ax plus b over 2a squared. And on the right side, you have minus c over a plus b over 2a squared. All right, you know that the left side can be factored as a perfect square, right? This is a perfect square straight away. So now you have x plus b over 2a squared, right? It's a perfect square. You have this number squared and this number squared, so you end up having those two in one bracket in a sum, and you square that. You square that sum. That's going to be same as the right side. So you have minus c over a plus b over 2a squared. The right side simplifies by using the exponent rules and finding a common denominator. All right, so you have a 2. Let's do it step by step. So you have minus c over a plus b squared over 4a squared. Now you're going to find a common denominator. Well, here you have 4a squared, so you're going to have to multiply this fraction by 4a. So you have minus 4ac over 4a squared plus b squared over 4a squared. All right, now you have a common denominator. Okay, let's write that left side again. Let's not forget that. Taking the square root, you get x plus b over 2a equals plus minus the square root of everything that was on the right side. So you have minus 4ac plus b squared, all of that over 4a squared, because it's a common denominator. And then you can rearrange. You can rearrange the whole thing. You have x on the left side, and then you have plus minus square root of b squared minus 4ac over 4a squared minus b over 2a. Well, here you can simplify the square root. You have plus minus. Let's expand it out. You have b squared minus 4ac times 1 over 4a squared. And you have minus b over 2a. So you can simplify this to taking the square root of 4a squared. That's going to be 1 over 2a. And then you have the square root of b squared minus 4ac minus b over 2a. Notice how the first term and the second term have the same common denominator, 2a. So you can rearrange this. Let's put the minus b first. You would have minus b, then plus minus the square root, b squared minus 4ac. Oh, look at that. I forgot the c. 4ac. And then all of that over 2a. At the very top, you're left with x. So now you have to bring that x all the way down. And voila, you have the quadratic formula, which is x equals minus b plus minus the square root of b squared minus 4ac, all of that over 2a. This is your quadratic formula, right? That is the quadratic formula. In essence, the quadratic formula is just completing the square.